welcome back to another Just 5 Mins. It's a bit of a specific one this time around, so apologies. It's along the theme of episode 87 where we looked at Microsoft SQL Polybase for accessing external data, which is very good, by the way. Should really have a look into that. I am going to be working on some new videos and possibly even a subscriber sort of channel, but we'll see how that goes. Better create some decent content first. But anyway, along with this one, what have we got this time? So it's still Microsoft SQL, and it is SQL Server memory optimized tables. So as far back as SQL Server 2014, but certainly the latest features that I've been looking at over the last year were introduced in SQL Server 2016, 2017, that era. Okay, so they've been around for a while, and they are what they are. They're memory optimized tables. Those tables, not the whole database, only the specific tables that you create. If you create them as in-memory tables, that's exactly what they are. Though the data in those tables are stored in memory. Now, by default, they're in durability mode, which means essentially the data itself that you're reading is in memory, but there's a copy of the table, obviously being shadow created on the disk, along with the transaction log and things like that. Okay, but the fully durable memory optimized tables are fully ACID compliant, atomic, consistent, isolated, and durable. So it's a cool thing. But if you, as an example, and there's probably lots of other examples, but SAP, they created quite a while ago now, HANA database, which is a totally in-memory database, the whole thing. And it works in a similar way, I believe, is that it's got the transaction log on the actual disk and a shadow copy and all that. But you do need a rather big chunk of memory. I think it's something like a minimum of 128 gig of RAM or something. But obviously, the benefit is that most of what you're doing and working with is getting, it's not even hitting disk. Not at the time are you using reads and writes, and that is the same thing, but instead of the whole database being in memory, you've got the option of being very specific with certain tables. Okay, as I've mentioned, the way that they work is the memory optimized tables store the data in memory using multiple versions of each row's data. Get ready for this one. This technique is known as non-blocking multi-version optimistic concurrency control. Crikey, I could do with a cup of tea after that. But basically, it eliminates both locks and latches, as they say, thus achieving breakthrough performance. All row versions are maintained in the same table structure, and row versioning is used to allow concurrent reads and writes of the same row. So it's quite an important fact, that, actually. And like I say, by default, when you create an in-memory table, they are durable, okay, which means they're fully durable by default. So essentially there's the transactions on disk, there's essentially a shadow copy, a second copy of the table is maintained on disk in case your server decides to blow up, fall over, or run away, or whatever it might do. So it's got some really interesting aspects there. You can also have something called non-durable tables, where all the data is just stored in memory and it doesn't do anything with disk. Okay, so it doesn't copy the data to disk. It doesn't. So the thing is, that's a bit dangerous, isn't it? Well, it is for very critical bits of data, but you can imagine if you've got a lot of like lookup tables or stuff that gets referenced very quickly and probably is easy enough to recreate. So it's almost like a materialized table or view. Then that could come in really handy because it'd be exceptionally quick. But even if you don't go for the non-durable tables, the durable tables have got that added benefit behind the scenes. You're getting a copy of the data, the transaction logs getting written to disk. So So that's what I've got. Yeah, so certainly from SQL 2016, Azure SQL is covered as well, but only in the premium tier. Okay, but anyway, that's what we've got this time around. I will try to be a little bit more consistent with the updates on just 5 minutes, but I hope you're all well. And until next time, take care, and we'll catch you on the next one.